Students, how are you guys today? We are actually going to be looking at day 4. So if you go into your OneNote and find day 4 materials, we're going to start with the warm-up. So there's like some to-do stuff. Here's what we're going to do for today. I'm going to do one video of the warm-up, and then I'm going to do one video for the notes. Keep in mind, guys, I miss you. I wish I was in front of class teaching you right now, walking around the room, checking in on you, but unfortunately we're not. So here's what we have. So hopefully you're watching the videos and taking good notes. All right, on today's warm-up, what is the quotient? The word quotient, if you remember correctly, means to divide. So what we're going to do is we're going to take 12 times 10 to the negative 7, and we're going to place it over 4 times 10 to the negative 2. Now, when you get ready to do this problem, you're going to divide your coefficients and you're going to subtract your exponents. So go ahead and pause the video right now and practice doing this problem. So again, the first thing we're going to do is divide those coefficients. So not the x's, obviously. We're going to do 12 divided by 4. And 12 divided by 4, if you remember correctly, is 3. Big problem of the day right there. So we're going to have 3 times 10. The rule when you divide expressions with bases and exponents is to keep that base the same and subtract your exponents. But be very careful. You're taking negative 7 minus the negative 2 here. So you're subtracting those. Negative 7 minus negative 2. And you guys know by now that turns into a big old plus sign in the middle. So you have 3 times 10 to the negative 7 plus 2 is negative 5. This, make sure, is in scientific notation. Yep, 3 is a number between 1 and 10 times a power of 10. So we know that we ended it correctly with what we needed to do. So there's number 1. Number 2, simplify part A. Remember to keep the base the same and subtract your exponents. Pause and do that one now, please. So we're going to keep that base of 10 the same, and we're going to do 11 minus 5. So 10 to the 11 minus 5 is 10 to the 6th power. This one did not say find the value, so we're going to leave it just like that using the exponents. 2b, this is what, after grading some of your homework, I was really concerned that maybe we didn't quite understand the full impact of negative exponents. So what we're going to do is, this is a quotient taken to a power. So technically, everything inside that parenthesis gets taken to the negative 3 power. So that's step 1. Now, the main point of having a negative exponent, it goes to the other side of the fraction bar. And that's what you guys, I feel like, were maybe didn't watch the video or you didn't quite understand, not sure. Anything being taken to a negative exponent has to go to the other side of the fraction bar. So that x to the negative 3 is going to go down below. And that 2 to the negative 3 is actually going to come up top. So you flip it, because both of them are being taken in negative exponents. So when you do that, you end up with 2 to the 3rd. It becomes positive over x to the 3rd. It becomes positive as well. So negative exponents do not mean that you have a negative answer. It just means that you have to flip it to the other side of the fraction bar. We can go ahead and figure out that 2 to the 3rd power, 2 times 2 times 2 is 8 over x to the 3rd. So 8 over x to the 3rd is your correct simplified answer there. Again, negative exponents get flipped to the other side of the fraction bar. So for part C, I'm just going to write this one a little bit bigger over here, and we can break it down away from the other problem. First thing I'm going to do is I'm going to focus in on those those coefficients out in front, the 24 and the 28. And I'm looking at those like, man, it sure looks like I can reduce the 28 and the 24. What number goes into 28 and 24? 4 does. Divide top and bottom by 4. So 28 divided by 4 is 7. 24 divided by 4 is 6. So I just reduced that fraction to 7 over 6 to start. So I'm going to put my 7 there and my 6 there. 7 in the numerator, 6 in the denominator. Now we're going to focus in on our x's. If you look at the x's, they are absolutely top heavy. I have more on top than I do on bottom. So that's going to be x to the 12 minus 3, which leaves us x to the 9th power. They are no longer on the bottom. We had 12 x's being multiplied on top, 3 on the bottom, so that simplifies to 9. 9 x's would be left on the top. The next one, with the y's, there's a couple different ways you can do this one. I'm noticing that, first of all, this is a problem right there, that negative exponent right there. You can go ahead and move that to the bottom if you want now. So we know that that's going to move down below. That whole y value is going to come down below, but don't move the y to the 10th. It is not being taken to a negative exponent. So I know now that if I already had 10 and I bring down 3 more, we have y to the 13th on the bottom. The other way that you can look at this one is keep your base the same, keep the y the same, and do y to the negative 3 minus 10. Remember, you keep the base the same and subtract the exponents when you're dividing, and that is y to the negative 13th, which of course would come down here to the bottom. So if you were to keep the base the same up top, subtract your exponents, you get y to the negative 13th, but you know that has to go to the bottom. So this is your simplified answer for part C. I know there's a lot going on there, so just take it step by step, coefficient by coefficient, letter by letter, and you'll get there. Rewind the video if you need to. The last one, it's been a while, and I would absolutely hate for you guys to forget how to do this. So on number 3, I want you to write equation in point slope form that passes through the following points. Well, the first thing I want to remind you is point slope form, in case you've forgotten, is y minus y1. I'm going to write it over here, not right there. It's not a good idea. So y minus y1 equals m times x minus x1. So I'm going to go ahead and realize, oh shoot, we've got to find the slope. So here we go, x1, y1, x2, y2. Now we can start finding the slope. We're going to do negative 1 minus 3 over negative 11 minus negative 5. So negative 1 minus 3 over, my pen is totally messing up. Sorry, guys. Let's try this one more time. Negative 1 minus 3 over negative 11 minus negative 5. Be careful, all those negatives right there. So up top, we have negative 1 minus 3 gives us negative 4 over negative 11 plus 5 is negative 6. So now reduce that. Negative over negative is positive 2/3. Negative over negative is positive 2/3. Sorry. That is our slope. So our slope is 2/3. You can pick either point you want to plug in over here. I'll show you both. I'm going to do the first set, y minus 3 equals m, which is our slope, 2/3, times x minus negative 5. And of course, that turns into a positive 5 because it was x minus 5 there. So there's your first option. That is a very valid option for the first equation. The second equation, we're just going to plug in the second point. So y minus negative 1 equals our slope 2/3 times x minus negative 11. And both of those turn to plus. Y plus 1 equals 2/3 times x plus 11. So there's our second equation. So either one of these would absolutely. Okay, that's it for the warm-up today. So I'll stop the video and go make your notes video.